In problem 4.3.3, we have to draw the Lewis structures of three different ions or molecules. The first one is PO43-. So the first thing we're going to do is count the number of valence electrons we get to put in our Lewis structure. Phosphorus has 5 valence electrons. Each oxygen has 6, and there are 4 of them. And then we get 3 more valence electrons from the fact that the phosphate ion has a -3 charge. So overall, 6 times 4 is 24, plus 5 is 29, plus 3 gives us 32 valence electrons total to work with. So in this case, phosphorus goes in the center, and we can put the oxygens around it. So that has used 2, 4, 6, 8 electrons in each of the bonds. So now we're going to add lone pairs until we run out and hopefully satisfy our octets. So we've used 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Now we can double check. Does everything have a complete octet? 8, 8, 8, and 8. Remember, these are covalent bonds, so they share. So the phosphorus also has 8 around it. So everything has a complete octet. I used all 32 of my valence electrons. Now the only thing left is to add the last bit that we need, which is the brackets around the structure indicating the charge. Now we have to indicate the charge because that lets us know if we were to come across this not having just drawn it, someone else drew it and we were trying to figure out what they meant. Indicating the charge helps us to be able to count the correct number of valence electrons compared to what it should be, because if it didn't have the 3- charge, we would only have 29 valence electrons. So we're going to put the brackets around, and we'll have a 3- charge on the outside, and that's going to be the structure for phosphate. We can do the same thing for the sulfite ion in part B, SO3 2-. Sulfur has 6 valence electrons. Each oxygen also has 6, but I have 3, and then I have a 2- charge, so I get 2 more. Altogether, that's going to be 26 valence electrons. So I put sulfur in the middle, surrounded by oxygens. I've used 2, 4, 6 electrons to start with. 8, 10, 12, 14, 16, 18, 20, 22, 24, and 26 completes my octet on sulfur. Everything has 8. So once again, I put it in brackets and I indicate that -2 charge that we have. For the last one, part C, HONO, H has 1, oxygen has 6, N has 5, oxygen has 6, so altogether I have 18 valence electrons in this structure. This one is a structural formula, so it actually indicates to me how the atoms are bonded together. So it's HONO bond with single bonds. 2, 4, 6 electrons went into those single bonds. 8, 10, 12, 14, 16, 18. I'm out of electrons, and you'll notice I filled them in based on the electronegativity of the atoms, which is something that we are going to get into shortly in this unit. But so the most electronegative, oxygen got electrons first, and then nitrogen did. Hydrogen is satisfied with only 2. Both oxygens have 8, however, the nitrogen only has 6. So what I'm going to need to do is I'm going to need to take electrons off of an oxygen and form a double bond with nitrogen. Now you could do this one of 2 ways. You could remove this pair of electrons, or the one on top, it doesn't really matter, and double bond to that nitrogen. Now everything has 8, it's satisfied, that would be a valid Lewis structure. But you could have just as easily taken a pair of electrons off of this oxygen on the right-hand side and formed the double bond that way. This is an example of something we really aren't going to get into in this class called resonance. But both of these Lewis structures are correct, and both of them would be marked correct on quizzes and homeworks and such, as long as you had one double bonded O and N and one single bonded O and N, and everything had a complete octet. Now, in section 4 of this unit, when we talk about formal charges and oxidation states, we can actually get into which of these structures would be quote-unquote better and which would be more stable, but for now, both of these answers would be correct.